Hello dear students, welcome back to BYJU'S Exam Prep and I welcome all for this GATE Champion Series Discrete Mathematics. Hi, good evening Lalit Yadav, very good evening sir. Okay, and the fourth topic under this GATE Champion Series Discrete Mathematics is Graph Theory. Hi ABG, welcome G. Right sir. And this is about me, myself Sridhar Dhulipala. I am having 20 plus years of teaching experience and my qualifications are MSc Mathematics from JNTU Hyderabad and MTech Saka from NIT Karnataka Surathkal. And these are my achievements, and I am associated with Byjus from past 1.5 years, and we are working on a project called Recorded Gate Content, first of its kind, and we recorded visualized animated content for you people. Hi Anant Mohan, very good evening sir, welcome to you. And under BYJU'S Exam Prep app, you can find this category known as Learn with Video Lessons, where you can find all these subjects which were recorded by me. Discrete Mathematics, Algorithms, Engineering Mathematics, C Programming and Data Structures. Got it? So you can see all these subjects which were recorded by me sir. Right? So without wasting much of your time, let me start today's topic. That is Discrete Mathematics Part 4. We take up some workbook questions or practice questions or live workbook problems on graph theory. Right? So the first problem on your screen. Try this problem, sir. Please answer this question, my dear friends. Which of the following is degree sequence of a simple graph? Yeah. Any answers? Please. See, for degree sequence, we have a beautiful technique called Havel-Hakimi procedure or algorithm. Using that, we can check whether the given degree sequence is or given sequence is degree sequence. See, degree sequence means it is a sequence of degrees or degree sequence of a simple graph, my dear friends. Havel-Hakimi algorithm. Yes, Havel-Hakimi algorithm. Okay. So, the given degree sequence is a degree sequence of a simple graph or not, we need to verify. So, let me start with the first one, option A. Hello Tushar Babu. Very good evening. Okay, so let me solve this problem, sir. First one, 4, 3, 2, 1, 1. See, what we do is we start with highest. We write that in non-increasing order, that is decreasing order with equal fellows together. Degree sum as even. Sum of degrees is even. Okay, very good. That is wonderful idea, my dear friend. Sum of degrees is not even is also wonderful idea. Or you can say that there are odd number of degrees having odd degree. The number of odd degree vertices must be always even. That way you can verify, my dear friends. Wonderful. Good, my dear friends. Am I clear? 4, 3, 2, 1, 1. Here also, how many odd degree vertices? 3 odd degree vertices. In a graph, in any graph, the number of odd degree vertices must be always even. We should have even number of odd degree vertices, but we are having odd number of odd degree vertices. Therefore, it cannot be a degree sequence of a simple graph. It cannot be degree sequence of a simple graph. Right? Wonderful. Let us see option B. 7, 6, 5, 4, 4, 3, 2, 1. A is correct. A is correct. How can you have a graph with 3 odd degree vertices, my dear friends? How can you have a graph with 3? Sobhagya Naik saying C, and Tushar Sisodia given his own answer, or he changed it. C is false. Okay. What about B? Let us see. Highest degree vertex is 7. It is in non-increasing order, decreasing with equal fellows together. What you do is you remove the highest degree from next. What is this degree? 7. From next 7 degrees, you subtract 1. You subtract 1. So it is 5, 4, 3, 3, 2, 1, 0. See, after this process, sometimes this order may be changed. So what we need to do is we again rearrange that in the proper order. But this time we don't need to do that because it is already in the proper order. Sometimes after this step, the order may be changed. So we have to put it in the proper order, my dear friends. Now what happens next is 5. Highest order vertex, highest degree vertex is 5. From next 5 you subtract 1. 1, 2, 3, 4, you subtract 1. So then what happens? It is 3, 2, 2, 1, 0 and this 0 as it is. Next again rearrange it. Luckily no need of rearranging, it is already in the correct order. Highest degree vertex is 3. From next 3 you subtract 1, which gives you 1, 1, 0. Already 2 zeros are there, let them be there. Now again rearrange in the correct order. Highest degree vertex is 1 here in this list. Next 1 you subtract 1, all zeros. See, if you get all zeros means, the given degree sequence is graphic. See, if it is a degree sequence of a simple graph, then you call that particular degree sequence as graphic. You call that particular degree sequence as graphic, my dear friends. Why A is correct? Most of the people are saying A is correct. Oh, acha, there are 3 1. Okay, I thought only 2 1. Sorry, I taken wrongly. Sorry, I think then it's correct. I not checked that. Sorry, I thought only 2. Sorry. You are correct, sir. I haven't taken that wrong. I taken it wrongly. Okay, please be careful. So 4, next to 4 you subtract 1. To 2, 1, 0, 0, 1. You arrange them in the correct order. 2, 1, 1, 0, 0. Remove 2, next 2 you subtract 1, 0, 0, 0, 0. So it is also graphic. Sorry, I taken it wrongly, sir. I thought of giving 2 1s, but I given 3 1s. Okay, fine. I taken that question wrongly, so things will go wrong. So A is correct, A is graphic, B is graphic, so it can be MS cube, sir. It is MS cube. Okay, I thought of creating MCQ, but it become MS cube. 4 6ers, 2 3s, and so let us see the next slide. 4 6ers, 2 3s, and 2 2s. Here the number of odd degree vertices are even, no problem with that. Highest degree fellow is what, sir? Highest degree fellow is this fellow. Next 6 you subtract 1. So it is 5, 5, 5. Then it is 2, 2, 1, 2. See, the order is changed. You have to again put it in the correct order. 5, 5, 5, 2, 2, 2, 1. Remove 5. Next 5 you subtract 1. That is 4, 4, 1, 1, 1. This one is anyhow there. Now again write in the correct order. 4, 4, 1, 1, 1, 1. From first, remove the highest degree vertex or highest degree from the list. From next 4 you subtract 1, which is 3, 0, 0, 0, 1, which gives you 3, 1, 0, 0, 0. 3 is highest degree vertex. Remove it. Remove highest degree from the list. From next 3 you subtract 1. This becomes 0, minus 1, minus 1, 0. Whenever you find any negative entry in this list, you stop the process. It means it is not graphic. Therefore, only A and B are graphic, as you said, sir. Okay, sir. If you see, but you can't suggest them to give a proper graphic one. Am I clear? They just asked, yeah, that may be. Am I clear? That may be possible, but you can't do that in this problem. You can give that suggestions maybe by a mail to the GATE conducting organization. Hope you understand. Next one. The degree sequence of, I understand, sir. I'm just joking. You are joking, I'm also joking. Or you are giving an idea. Okay, it's good. The degree sequence of complement of a simple graph having degree sequence. So I given degree sequence of a graph, you need to identify the degree sequence of its complement. What do you mean by complement, my dear friends? What do you mean by complement, my dear friends? See, the complement is obtained by how? It will have same vertices as the original graph, and two vertices are adjacent in complement if and only if they are not adjacent in the original graph. That is, if two vertices are having an edge between them in the original graph, between those vertices in the complement graph will not find any edge. If two vertices are non-adjacent, means there is no edge between two vertices in the original graph, now in the complement you will find an edge between those two vertices. For example, if this is your graph, the complement is obtained by taking same vertices but the edges which are not present in the original graph. Am I clear? These are the edges which are not present in the original graph, and you have to remove the edges which are present in the original graph. So this is complement of the graph, my dear friends. Okay, -1 from each degree. Wow, -1 from each degree is a good idea. See, my dear friends, if you observe this, what is degree of this vertex 2, what is degree of this vertex 2, what is degree of this vertex 2, what is degree of this vertex 2? And in the complement, what is the degree of this 1, what is degree of this 1, what is degree of this 1, what is degree of this 1? First of all, what we need to understand is a graph and its complement. If you union them, that is, if you union these two fellows, if you take the union of these two fellows, you are going to get a complete graph with that many vertices. You are going to get complete graph with that many vertices. K4 you are going to get. Complete graph you are going to get. Am I clear? So, the degree of this vertex plus degree of this vertex must be equal to degree of vertex in the complete graph. Degree of the vertex in the complete graph. Okay? So, if you want to get degree sequence of complement, the degree sequence of complement, for example, degree sequence of G is say D1, D2 and so on, say Dn, then degree sequence of complement graph would be, what is it? Because degree of this plus degree of this must be equal to how much? Degree of this vertex plus degree of the same vertex in the complement. What should be sum of these two fellows? What must be D1 plus D1 complement? What must be D1 plus D1 plus D1 complement? D1 plus D1 complement should be equal. Don't worry about number, I am telling you generally. I am telling you general story. D1 plus D1 complement should be equal to what? The degree of complete graph. Degree of the same vertex in complete graph, and degree of the same vertex in complete graph with n vertices would be n minus 1. So if D1 is given, how to get D1 complement, sir? It is n minus 1 minus D1. It is n minus 1 minus D1. So the degree sequence of the complement graph is given by n minus 1 minus D1, n minus 1 minus D2 and so on, n minus 1 minus Dn. Okay, correct. Am I clear? N minus 1 minus D1. N here in this particular case, what is n? How many vertices are there in this graph? 8 vertices are there. So if you have degree sequence of this particular graph, which is 7, 6, 5, 4, 4, 3, 2, 1, with n is equal to 8, this is degree sequence of the graph. Then what is degree sequence of its complement, sir? It is simply n minus 1. N minus 1 means what, sir? 7. 7 minus this degree, that is 0. 7 minus this degree, 1. 7 minus this degree, 2. 7 minus this degree, 7 minus 4 is 3. 7 minus 4 is 3. 7 minus 3 is 4. 7 minus 2 is 5 and 7 minus 1 is 6. Of course, it is in increasing order. We have to write it in non-increasing order. So just write down from highest to lowest. 6, 5, 4, 3, 3, 2, 1, 0. See, even if you write, there is nothing wrong, sir. Generally, we use that non-increasing order only. Generally, we use that non-decreasing order. Why you are writing 39, sir? What is the D39? Acha, you are saying for every vertex, what is the answer? Acha, sum of degrees in B you are finding. Okay, that also you can do it. Yeah, that is also very valid, good question for gate point of view, sir. That is also very good, valid question for gate point of view. He gives the degree sequence of graph and he can ask you what is sum of degrees in G complement or number of edges in G complement, they can ask you. Okay, so please answer this because you are answering anyhow all this. Please tell me number of edges in G complement. Please tell me the answer for this. Number of edges in G complement. Babu Tushar Sisodia, sum of degrees is twice the number of edges. What about number of edges in G complement? Please answer this question, my dear friends. Yeah. So if you add up 6 plus 5, 11, 15, 18, 21, 22, 24. 24 by 2. Sum of degrees is, because sum of degrees is 24, number of edges is sum of degrees by 2, which is nothing but 12. Very good Anant Mohan and very good Tushar Babu. Super. So all these kind of questions are possible. See, in graphs, generally the story is very simple, sir. We have only vertices, edges, and the story is all about the vertices and edges only, nothing more than that. Same as G. Is it same as G? Number of edges in G and number of edges in G complement will be always same. Oi, Akshay Sharma. Akshita Sharma, sorry. Akshita Sharma. Very good. You removed your comment. Very good, very good. Simple problems. I just taken some simple problems, sir. Because as I told you, simple general understanding of this sum of degrees and all. I taken some problems today, so that we feel like solving the problems. Am I clear? I'm not went to this theorems part much. I don't want to trouble you with that today. E is equal to E here. Okay, a graph consists of 4 vertices, each of degree 3 and an isolated vertex. The number of edges in number of edges in the graph is what? How many edges are there in the graph? So simple problem. We all know that sum of degrees of vertices is twice the number of edges. 4 vertices of degree 3. So their sum is 4 into 3, 1 vertex of degree 0. So this should be equal to twice the number of edges. So edges must be equal to 12 by 2, yani 6. 12 by 2. Babu, Rish, Kumar Bharadwaj. Why 3, sir? Akshit Sharma good, Akshita Sharma good, Lalit Babu good, Anant Mohan good. Why Rishi Kumar Babu? Why your answer is wrong? Wrong, no? Saubhagya Nayak, very good, sir. Yeah, Rishi Kumar, super. Yes. Okay. So, of course, this is the place where you can do mistakes. Do it happily, correct it. Next one. If a graph having 17 edges, very good Abhi, very good Tushar, very good. If a graph having 17 edges contain 3 vertices of degree 4, 4 vertices of degree 3 and remaining vertices of degree 2, then find total number of vertices. Simple problems, sir. These are Lilliput problems. But these are enough to trouble most of us. Am I clear? Because in examination, suddenly you do some mistakes, silly mistakes. And they want you to do that. Trap. They'll trap you, sir. Anant Mohan says 12. Very quick today, Anant Mohan. I think you like solving problems. Good. Total number of edges is 17. 3 vertices of degree 4. So let us find out sum of degrees of vertices. 3 vertices of degree 4. So the sum must be equal to 3 into 4. 4 vertices of degree 3. Their sum must be equal to 4 into 3. Remaining we do not know. Let us call it as x of degree 2. And this is the story given, my dear friends. But sum of degrees must be equal to twice the number of edges, where edges is given to you. So 12 plus 12, 24 plus 2x is equal to 34. Therefore 2x is equal to 10 means x value is 5. X value is 5. X is number of vertices of degree 2. X is number of vertices of degree 2. But you need total number of vertices. Total number of vertices, which is 3 plus 4 plus x. X is 5. So that is 12. Super cool. Next problem. It was a GATE question. I just modified it, sir. A GATE problem, so I just modified it for convenience. Small variant, let us solve it. The original question was with 12 here, 12 and 12 here. So I just made it simple for us. See here, the vertices are labeled like this. Ij is the label of the vertex. See, generally vertices are labeled with 1, 2, 3, 4 or A, B, C, D, or with the names. You can name each vertex with some favorite names of your film stars or whatever superstars. Am I clear? But here he labeled the vertices with ordered pair. That is, each label is an ordered pair. Each label is ordered pair. Ij, where I varying from 1 to 6, j varying from 1 to 6. So it is actually 6 by 6. Total 36 vertices are there, and the vertices are the lattice points only. That is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Yeah, 6 by 6 matrix. Here the vertices are labeled like, this is labeled as 1, 1, this is labeled as 1, 2. Like this, they are the vertices are labeled. The vertices are labeled. Now if you observe, when two vertices are adjacent, he given the condition for adjacency of two vertices. See, their x coordinates difference must be less than or equal to 1. Their y coordinates different, or the first coordinate difference should be less than or equal to 1, and their second coordinate difference is also less than or equal to 1. First and second coordinate difference is 1. Then the two ordered pairs, or the vertices representing the two ordered pairs, becomes adjacent. So that is the 56. Let us see. That is the idea. So for this, generally people take the idea of degree. For that, first of all, let us see. You please tell me, this fellow is adjacent to how many vertices? This first, or the corner vertex, is adjacent to how many vertices? Corner vertex is adjacent to how many vertices? Because xy coordinate or first and second coordinate difference must be 1. hardly how much distance any vertex can travel, or any vertex can be adjacent to how many vertices, my dear friends. See, if you take any vertex, the first coordinate is having difference 1 with any other fellow, means that fellow should be either here or here or here or here. Because if this is a coordinate, say ij, what is this particular coordinate? I plus 1j. What is this particular coordinate? ij plus 1. What is this particular coordinate, sir? What is this particular coordinate? J value reducing, ij minus 1. If you see this particular coordinate, it is I minus 1j, my dear friends. And if you see these coordinates also, which are at diagonals, here what is happening? It is I plus 1, j plus 1. Here what is happening, sir? This fellow is I minus 1 and j plus 1. What about this? This is I minus 1, j minus 1. And what about this? I plus 1, j minus 1. So if you see for any vertex generally, the vertices which are at right, left, top, bottom, this diagonal, bottom diagonal, and left diagonal and right diagonal. Okay, so these are the 8 points which can be adjacent to any vertex. For any vertex, these are the possible vertices which can be adjacent to that. Am I clear? Now if you see the corner fellows, for this we have only 1 to 3 such fellows available, because we don't have this point, these points are not available. So for this fellow, only 3 vertices can be adjacent. So the degree of this vertex can be 3. Similarly, for this fellow also same story. This can be adjacent to only 3 fellows. This fellow also can be adjacent to 3 fellows. This fellow also can be adjacent to 3 fellows. So degree of each corner vertex will be 3 only. Is that clear? Next, if you see any of these vertices, that is end vertices which are not corner vertices. End non-corner vertices. What is the fate of this fellow? You take any fellow. This fellow is adjacent to what? This fellow can be adjacent to this, and this. So any of these end vertices, end non-corner vertices can be adjacent to 5 vertices. Okay. So what happened? Degree of each of these fellows will be 5, my dear friend. Degree of each of these vertices will be 5. So we completed corner vertices. We completed end vertices. Top, bottom, left, and right, left and right end vertices we completed. We know the story of this fellow. Now comes the internal vertices. All these are internal vertices, and each of them will be adjacent to like this. Each of internal vertices will be having the same story. So this fellow can be adjacent to what, sir? This fellow will be adjacent to 8 vertices. So degree of each internal vertex will be 8. So with this you can conclude the story, my dear friends. Okay. How many corner vertices? Corner vertex. How many corner vertices? Corner vertices are 4, and degree of corner vertices. Degree of these vertices will be what? What is degree of each of these corner vertex? Degree of each of the corner vertex is 3. End vertices. Number of end vertices. How many end vertices are there? Because 4 here, 4 here, 4 here, and 4. 16 end vertices are there. And what about degree of each end vertex? Degree of each end vertex is 5. How many internal vertices are there? How many internal vertices are there? How many internal vertices are there? How many internal vertices, sir? Internal, how many will be there? 1, 2, 3, 4. Okay, 4, 16 internal vertices, correct? And what is degree of each internal vertex? Degree of each internal vertex is 8. Internal vertices 28. How, sir? Internal 1, 2, 3, 4. 1, 2, 3, 4. 4, 4, 16 only, na? See, totally it is 6 by 6. When you remove the outlier, this and this is gone left, and that is you remove 2 rows and 2 columns, it becomes 4 by 4 only, na? So now sum of degrees you find out happily. What about sum of degrees? 4 into 3, 16 into 5 plus 16 into 8. 4 3 is 12, 80, and 160 minus 32, that is 128. 140, 220. But that should be equal to twice the number of edges. So number of edges must be equal to sum of degrees by 2. That is nothing but 110. Why 130, sir? Is it 260 or 140, no? So now that you need to generalize AB de Villiers. 6 के जगह 100 होगा तो क्या होगा? That you need to generalize it. Any corner vertex will have degree 3 only. Even if it is 100 by 100, any corner vertex will have degree 3 only. And end vertices will have degree 5 only. Internal vertices will have degree 8 only. That is fixed. That is fixed for whether it is 4 by 4, 5 by 5, height 10 by 10 or 100 by 100. You can answer that question, my dear friends. Now you can answer. See, for understanding this it will take time. But now even if you give me 100 by 100 also, even if you give me 100 by 100, there are 4 end vertices. There are 4 end vertices, each of degree 3. So 4 3 is 12. The degree of those fellows will be 12. And how many end vertices? Because 2 are gone. 98, 98, 98, 98. 98 into 4. 4 8s 32, 36, 39. 392 each of degree 5. How many internal will be there, sir? How many internal will be there? Because it is 100 by 100 now. You remove 2 rows, 2 columns. It becomes 98 by 98. So 98 by 98 each of degree 8. It won't do. Once you understand this, see, generally we don't solve it for 6 by 6, sir. Even if it is given, I don't solve it for 6 by 6. Here, what you need to understand is end vertex degree, external vertex degree, internal vertex degree. This would be same for 100 by 100 matrix also. See, even I solved it 100 by 100. I solved it 100 by 100. Okay? Each of degree 8. Same story, na? 4 end vertices will change. This will change, but these numbers will not change. 8, 5, 3 will not change. This will not change, na? So that is what counting means. That is what logic. But if it is rank deciding question, time consuming, you should do it last. Some people, what they do, they start with this problem. They will not get somewhere after doing some work, they feel it takes time. Okay, now they are not able to decide whether to continue or not. So they waste 10 minutes. Some people waste 20 minutes, then they stop and they go for other problems. See, whenever any problem takes more than 1 minute, 1 minute also very big, sir, actually, initially. You have to read all the 65 questions. Those who don't read all the 65 questions will never qualify competitive examination. 65 in the sense maximum number of questions. Every question you should read. Those who don't read the question, they are out. Remember that. Okay? That's the idea. See, now I solved it for 100 by 100 now. I can solve it for 100 by 100, 1000 by 1000 also I can solve it. And AB de Villiers, I want you to answer this. I want you to give number of edges for this problem in the comment section. In the comment section, AB and everyone who is watching, I want everyone to answer this for 100 by 100. Or you take a different number. If you don't like 100, some people take 100, some people take 50, some people take a different number and answer this. Okay. See how 98 by 98. See if it is 6 by 6, na? 6 by 6 means what? You remove this, you remove this, you remove this. Remaining all are internal vertices. Remaining all are internal vertices. Okay. Remaining all are internal vertices. So how many values are gone, sir? Here one and here one. And that is it, na? This is. Are you able to follow? This row is gone, this row is gone. Total 100 means this is 99. If you remove 99, if you remove 98. Same is the case here also. 100, one column gone. Two columns gone. From 100, two columns. From 100, two rows are gone. That's it. 98 by 98. Vanakkam, sir. Keshav, Harish, Vanakkam. Everyone take different number. Yeah, you take 1000 also. Why not, sir? With 117, does it happen with 117? Just see, sir, how many internal will be there. You have to check that properly and answer. With 113 also, I think it's possible, but the internal number of internal vertices will change. External will be same. Internal will have some problems. So please check Saubhagya Nayak. Internal vertices, how many will be there? Please check that. There. See, total 100 rows and 100 columns are there, no? You remove two rows, so minus 2, which is 98. You remove two columns, 100 minus 2, 98. It's not like that, sir. Next problem. Agla samasya. Next problem. If G is a graph with 13 edges and minimum degree 3, then maximum number of vertices in G will be what? If G is a graph with 13 edges and minimum degree 3, the maximum number of vertices in G is what? Babu Lalit Yadav, is that clear? Did I make it clear to you? Lalit? Harish, it is clear. What? Lalit. You asked me once again, I said whether it is clear to you. Yes, good. Answer for this problem, sir. Good, sir. Lalit Yadav says 8. See, they are related in the sense that both are given by IIT professors. The questions are framed by IIT professors. Algo also will be there. Algo ka bhi GATE session, GATE champion series I am only taking. I think next week or next week. Okay, it will be announced soon, sir. In the my Telegram group, you will get the notification. My Telegram group is CS_Sridhar. Please join my Telegram group, all of you. Please join the Telegram group. Yesterday's PDF I not uploaded. Both the PDF I'll upload after the class. Both the PDFs I will upload after the class. See here, this is a very interesting result. Small delta less than or equal to 2e by v less than or equal to capital delta. The most important result it is, sir. It is the most important result. You can ask number of questions based on this. In this problem, minimum degree is given, number of edges is given. He is asking about upper bound for number of vertices. So we take the left hand side inequality, that is delta is 2e by v. Delta less than or equal to 2e by v means v less than or equal to 2e by delta. Please, my dear friends, whenever you are looking for any value less than or equal to, you should take floor of it. Okay? So if you want to know the maximum value of v, the maximum v is given by floor of this answer. So that is 2 into e. What is e, sir? Number of edges 13 by minimum degree 3. So that is 26 by 3, which is 8 point something. Floor of 8 point something is 8. So the answer for this problem is 8. One of the interesting important variant, my dear friends. See, it is a okay, any graph, no? Yeah, it could be that, my dear friends. Yes, it could be that. Lalit Yadav, yes, because it is not just for simple graph. This result is for any graph. This result is true for any graph. You are correct. You are correct. Next one, number of edges in a 3 regular graph with 10 vertices. Simple problem. Another simple problem. Today I came up with all easy problems only. Three regular graph, you give an answer 15. Someone says 15, someone says 8. What is it? Three regular means degree of each vertex is 3. 3 regular means degree of each vertex is 3. So we do not know number of vertices now. Okay, 10 vertices. Number of vertices is given as 10. So sum of degrees must be equal to twice the number of edges. And because degree of each vertex is 3, 3 plus and so on. 3 how many times, sir? 3 plus 3 and so on. This must be equal to how many times, sir? Because 10 vertices are there, 10 times. That is 30 is equal to 2e, yani e is equal to 15. Can I have 3 regular graph with 9 vertices? Can I have 3 regular graph with 9 vertices? Why? Why? Why not? Why is that? Why so? Why is so much partiality? Yeah. The sum of degrees must be even, or the number of odd degree vertices in any graph must be even. There should be even number of odd degree vertices. So 3 degree we cannot have for 9 vertices. We cannot have 3 degree for odd number of vertices. Very good, Anand Mohan. Very, very good. The number of edges in Q5. Q5 you all know, cube, n cube you all know it, n cube you all know it, no? See, this is n cube, it is defined like this, sir. It is a simple graph, okay, with two power n vertices, where the vertices are labeled with binary strings of length n and two vertices are adjacent if and only if they differ in exactly 1 bit position. So that is a definition for n cube. We denote it by qn, my dear friends. We denote it by qn. No problem, sir. I given the definition now. 80, he says 80. I don't think so. Yeah, they differ in single bit. So Q1 means binary strings of length 1. This is 0, this is 1. So this is Q1. Q2, if you want, don't worry sir, what you do is you take 2 copies of Q1. You take 2 copies of Q1, that is 0, 1, 0, 1. What you do is you join these fellows and just make the next bit different. Again you join these two fellows and you just make the next bit different. Then you can get Q2, my dear friends. Similarly, if you want to get Q3, you take 2 copies of Q2. You take 2 copies of Q2 like this, 0, 0, 0, 1, 0 and 0, 1 and 1, 1. Here also 0, 0, 1, 0, 0, 1, 1, 1. What you do is you join the corresponding vertices. While joining, what you do is you make it 0 and you make one of them 1. Okay, you join these two fellows, you make it 0, you make it 1. You join these fellows, you make it 0, you make it 1. Join these fellows, you make it 0, you make it 1. This is 3 cubes, sir. This is 3 cubed. See, the logic is very simple, sir. Okay, I don't have space for this. No problem, I'll create it. Yeah, I created the space. Now look here. See, my dear friends, how many vertices are there? 2 power n vertices are there in n cube. In n cube, 2 power n vertices are there. Okay, let me write for Q5. In Q5, how many vertices are there? 2 power 5 means 32 vertices are there. Why? 2 power 10 by 2. Why, sir? Q5 means 2 power 5, na? 32. And what is degree of each vertex? What is degree of each vertex? See, if you see Q3, degree of each vertex is what? 3, 3, 3. Q2, degree of each vertex is 2, 2, like that. So here Q5, degree of each vertex is what, sir? 5. Degree of each vertex is 5. See, my dear friends, if you want to understand a particular concept, either you should follow my story. Here I am giving you the story. You should hear this story so that you can recollect it. Suppose you understand it a different story and you want to link up with this, definitely there will be some problem. Am I clear? See, that is what you should not do it. Suppose you forget something, if you are hearing for the again or you are hearing it again, concentrate. See, don't try to match what I am saying with that. That may be different story which you are thinking about it. So please hear carefully. See, 2 power 5, I just told you, here I given definition, simple graph with 2 power n vertices. 5 cube means simple graph with 2 power 5 vertices. See, n cube is a simple graph with 2 power n vertices, whose vertices are labeled with binary strings of length n, and 2 vertices are adjacent if and only if they differ in exactly 1 bit position. That is the story. Okay, that is the story. Now, if you say Q5, how many vertices are there? 2 power 5 vertices, that is 32 vertices. The vertices are labeled with binary strings of length 5. Now, if you observe, Q2 degree of each vertex is 2, Q3 degree of each vertex is 3. Similarly, degree of each vertex in Q5 is 5. Degree of each vertex in Q5 is 5. Anant Mohan, wait, I'll answer your question. Wait for some time. Now, what about sum of degrees of vertices? This should be equal to twice the number of vertices. So, degree of each vertex is 5, 5 plus 5 plus 5. How many times, sir? How many times 5 is added? 32 times, because 32 vertices are there, 32 times it is added. So 32 into 5 is equal to 2e. Therefore, E is equal to 32 into 5 by 2. 16 into 5, which is 80. Good. Anant Mohan, very good. That is answer. Oh. Hope you understand. Hope you understand. Or you can simply say n into 2 power n minus 1 is number of edges. In general, if you want to say, yes, degree of each vertex is n. Why, sir? Each vertex is labeled with n. Each vertex is labeled with a binary string of length n. And this vertex will be adjacent to another vertex if it is differed by exactly one bit position. So first bit position, if it is differing, one edge. Second bit position, it is differing, one edge. Third bit position, if it is differing, one edge. Nth bit position, it is differing, one edge. So for each bit variation, there is one edge, my dear friends. So degree of each vertex will be exactly n. Degree of each vertex will be exactly n. N into 2 power n minus 1, perfect, Lalit Yadav. Yes. Super cool. Yeah, next one. Akshita Sharma, yes sir. Good. Agla samasya. Next problem. No problem. Anand Mohan, you are giving answer and you forget what I was doing. Please see the recorded video once again. Anand, okay? Just take two Q2s. Corresponding vertices you join. While joining, at one place you put 0, at one place you put 1. That's it. That is a simple logic. The next one he says 64. I asked having odd number of edges. Acha, for unlabeled it is, not for labeled. Oh, nowadays people are also answering this for unlabeled. I do not know, sir. For unlabeled also you can do it, I do not know. I should know it. See, this result can be answered for labeled, for unlabeled, because, see, I'll tell you simple logic. If it is unlabeled with 3 vertices, this triangle only one is possible. With the labeled, the stories will be different. My dear friends. Okay, if I remove the labels, now look at this. This fellow is different from this fellow. These two are different as a labeled graphs, but unlabeled graphs, these two are not different. So finding number of unlabeled graph is not that easy, my dear friends. Finding number of labeled graph is not that easy, my dear friends. I'll explain. See, my dear friends, there are 4 labeled vertices. And this result is for labeled vertices, not for unlabeled vertices. Most of the people have this particular confusion, my dear friends. Okay, if you are having 4 labeled vertices, 4 labels or 4 vertices, then maximum number of edges would be Because n vertices are there, how many edges are possible? Maximum number of edges, n into n minus 1 by 2. N into n minus 1 by 2. That is maximum number of edges. So 4 means here it is 4 into 4 minus 1 by 2, which is nothing but 2 into 3, that is 6. 6 edges are possible. How many edges are possible? 6 edges are possible. So each edge is having two possibilities. Either it can belong to your graph or it may not belong to graph. So number of simple graphs with 4 labeled vertices would be, number of simple graph with 4 labeled vertices would be 2 power 6. Number of simple graph with 4 labeled vertices would be, 4 labeled vertices would be 2 power 6. The same thing can also be done like this. Out of 6 edges, you can have a graph with 0 edges, number of graphs with 1 edges, number of graphs with 2 edges, and so on, number of graphs with 6 edges, which is 2 power 6. This is one more way of doing it, my dear friends. Very good, Prajwal, very good. So he is asking number of simple graphs having odd number of vertices or odd number of edges. So when you want odd number of edges, it is 6c1 plus 6c3 plus 6c5, which is nothing but 2 power 6 minus 1, which is 2 power 5, yani 32, my dear friends. So the answer is 32. Half of them will be even and half of them will be odd. You can do that also, yes. So 32 is the right answer for this, my dear friends. 32 is the right answer. Hope you understand. Yeah, it's not odd number of vertices, sir, odd number of edges. Did I written vertices or what? Edges, no? See, discrete mathematics, you have to be very careful with 3 topics. Okay? Logic, relations, posets, equivalence relations, lattices, and graph theory. These are the 3 topics which can trouble you. Then advanced topic, advanced counting, generating functions, recurrence relations, of course combinations and permutations with repetitions. These ideas are, that may little trouble you if you are not comfortable with those topics. You have to be comfortable with those topics, my dear friends. Okay? Those who are not comfortable doing self-study can connect to me separately. I'll help you out how to prepare for them. Am I clear? Even if you are doing self-study also, you can connect with me, my dear friends. Okay? I'll help you for discrete mathematics. It is not as straightforward as it looks, but if you understand, it is the easiest topic, my dear friends. Scoring, easily you can score marks in this. We just need to fix proper results. In discrete mathematics, every time I find 50 to 60% direct questions, 40% they just vary the things. With terminology they trouble you, okay? They can trouble you with terminologies, they can trouble you with different ideas, sir. That they may do it, but otherwise, discrete mathematics, you can mostly score things directly, sir. Okay? Which of the following is, oh, wow, bipartite? Which of the following graph is bipartite? See, don't pressurize yourself, sir. Competitive examination with pressure you cannot, okay, generally Of course, some people, they are under pressure, they perform better. That is a different story. But you should not unnecessarily pressure your mind, my dear friends. Am I clear? Under pressure, when you do it, okay, already you have this trouble learning so many subjects. The other trouble is of cracking GATE or getting good rank and all. See, the rank should be side effect of your preparation. B, D, D, B. Which of the following is bipartite graph? See, my dear friends, the answer for this problem is, by looking at it, you can answer. B, C, D is the answer. It is MSQ. These three fellows are bipartite. Not BD, sir, B, C, D also. Every tree is a bipartite graph. Every tree with 2 or more vertices. Every tree with 2 or more vertices is a bipartite graph. Okay. How D? See, the idea of bipartite graph is you can partition the vertices in such a way that vertices in the same set do not have adjacency. Only vertices in different parts are adjacent. I'll make it, sir. Don't worry. I'll make it for you. Can you make it like this? Yeah, Anant Mohan. The idea is every cycle is even cycle. In a bipartite graph, every cycle is even cycle, then it is a bipartite graph. Is that clear? In a bipartite graph, every cycle is even cycle. So tree, every cycle is zero cycle. Zero means even. Because there are no cycles, zero cycles it is having. Every cycle is zero cycle, therefore it is a bipartite graph. Here this is having a odd cycle, so it is wrong. Here every cycle, it is actually, power set of A with 3 elements with subset relation. So that is obviously, okay, that one you can consider or whatever, okay. See, obviously here it is a bipartite graph, my dear friends. You can easily, it is actually Q3. Actually, it's not that, it is Q3. Actually, it is Q3, sir. What is it? It is Q3. Q3 graph. Q3, Qn, n cube is bipartite. Because of that, it is bipartite. And this one, we can easily separate into 2 parts. Rahul Negi NP. What is NP? Is that okay, sir? See, Lalit, that is fine, sir. That is all common, my dear friend. Lalit, that is common, natural phenomena. So don't take it, seriously. That is natural phenomena. For see, you may be saying I am the person. I generally see mostly around 80 to 85% people are having same problem, and that's why number of people qualified for GATE would be very, very simple, very less only. Okay, but you are doing quite good, not that bad. Okay, So that is not a big issue for you, sir. You can easily do that. Don't be in hurry. First thing is, don't be in hurry. Okay, and don't put additional pressure of scoring it or definitely answering it. Don't put such additional pressures, my dear friends. Okay, no one should put additional pressure. Mathematics, you should do it with cool mind, tanda tanda, cool cool. Maximum number of edges in a bipartite graph with 7 vertices. Anant Mohan, option is B. So what is it? It is maximum number of edges in bipartite graph with n vertices is given by maximum number of edges in a bipartite graph with n vertices is given by n square by 4 floor of it. Yes. N square means what, sir? 7 square, 49 by 4, which is 12 point something, yani 12, my dear friends. N by 2, but here it is not n by 2, n by 2. 3 in one side, 4 in one side will give you maximum number. 3 into 4 is the answer, that is 12 is the maximum. Floor, yeah, floor of it. Floor of n square by 4. Is the idea clear? One more simple problem. Yes, Tushar, very good. Sai Alekya, very good, sir. Very, very good. Maximum complete graph with 21 edges. So we do not know number of vertices. Let us say n is number of vertices. Then because it's a complete graph, it will have maximum number of edges. So number of edges should be equal to n into n minus 1 by 2, and that is given as 21. That means n into n minus 1 is equal to 21 2's 42. So two consecutive numbers whose product is 42. What are those two numbers? 7 and 6. So n should be 7. N should be 7. Once you have n, it is a complete graph with 7 vertices. That is, it is K7. What is maximum degree, my dear friends? See, my dear friend, complete graph, every vertex is having same degree, and the degree is 6, my dear friend. Why 7 you are writing, sir? Degree is 6. Now maximum degree is 6. In a complete graph, maximum degree of any vertex is 6, not 7. Chaudhary, Nayak and Negi. Simple problem only, na? See, today I don't want to trouble you with, complicated general questions I want to see, which are all asked. All these questions were gate questions only, little varied. Okay, I just, Oi Babu, Lalit Babu, number of vertices 7. Vertices 7. But maximum degree of any vertex is? Yes, right. Maximum degree in a complete graph will be n minus 1. See, in Kn, maximum degree is n minus 1, and every vertex is having same degree, sir. And number of edges would be n into n minus 1 by 2. What happened to this? Today my handwriting is very bad. N into n minus 1 by 2. Got it? Like this. Which of the following cannot be number of vertices in a self-complementary graph? Line, so please tell me, if you are having 8 vertices, maximum how many edges you can have? With this many vertices, what will be the maximum number of edges? With 8 vertices, what will be the maximum number of edges? 8 into 8 minus 1 by 2. That is 4 sevens 28. So when you have 28 edges, self-complementary means graph and its complement are same. They should have same number of edges also. So I can divide 14 for graph and I can give 14 edges for its complement. That is possible. With 9, maximum edges would be how much, sir? What is the maximum edges with 9 vertices, sir? 9 into 9 minus 1 by 2. So 8 by 2, that is 4. 9 4s 36. Even 36 I can divide into 2 parts. One is 18 for graph and 18 for its complement. With 9 someone said that is wrong answer. So 10 looks beautiful, but with 10 maximum edges would be 10 into 10 minus 1 by 2, that is 45. So if you have 45 edges, you cannot have self-complementary because graph should have half number of edges and its complement should have remaining half edges, which is not possible. So this is not possible. Which of the following cannot be? So cannot be here, so this is the correct answer. What about the next one? Next one is possible. Twelve means 12 into 12 minus 1 by 2. That is 6, 11, 66. 66 is also possible. See, actually what happens, graph and its graph will have n vertices. Number of edges in the graph is n into n minus 1 by 4. This will be the number of edges in the graph, because number of edges in the graph plus number of edges in its complement should be equal to n into n minus 1 by 2. But because E and E complement are same, self-complementary, number of edges must be same, that is 2E must be equal to n into n minus 1 by 2. Therefore, E must be equal to n into n minus 1 by 4. So, number of edges must be of the form n into n minus 1 by 4. That means either 4 should divide n or 4 should divide n minus 1. So, when 4 divides n means that number of vertices must be of the form 4k. When 4 divides n minus 1 means n must be of the form 4k plus 1. So, the number of vertices must be of the form 4k or 4k plus 1. This 8 can be written as 4 into 2. This 9 can be written as 4 into 2 plus 1. So, these two are possible. 12 can be written as 4 into 3. But this cannot be written in terms of 4 or 4k plus 4k plus 1. 4k or 4k plus 1. So, this is not having 4k resolution. This is not having 4k resolution. Therefore, it is not possible. Is the idea clear? Yeah, 4k or 4k plus 1 must be the form of number of vertices in a self-complementary graph. Must be number of vertices in a self-complementary graph. Next one. Still have energy? Why people are reducing? I have few more problems to complete today's class. Euler graph is a graph, okay, it's a connected graph in which connected graph having Euler circuit. Why to write so much? Euler graph is a graph which contains Euler circuit. What is Euler circuit, sir? It is a closed walk containing all the edges of the connected graph in which no edge is repeated. It is a closed walk in a connected graph containing all the edges with no edge repeated. Vertex may be repeated, edge cannot be repeated, sir. See, my dear friends, this real life applications, all these are bullshit, nonsense. Don't get into that, my dear friends. Mathematics is logic, not magic. So don't get into real life, then only if I visualize you can remember. Okay, now you remember a plus b whole square formula? For a plus b whole square formula with real life example you remember, or a plus b whole square you remember? See, don't tell me all these fake excuses, my dear friends. Okay, you have to understand the logic. Okay, don't connect with one-to-one correspondence. It's not a daily labor job. Learning mathematics is not daily labor job where you do this work, you get this much amount, you do this job, you get this much amount of that. That kind of methodology does not fit or does not work for mathematics. And we cannot have one-to-one correspondence for every real life application with every formula, which is nonsense. Okay, so don't do that, my dear friends. See, there may be one or two examples people may give, don't go with it. That is not the way to learn mathematics. It is logic. You have to get the logic first. Am I clear? Yeah. Yeah, you remember that. That's your problem. You can remember that way only means, see, for everything you have to write a story means it's not possible. That's what I'm trying to tell you. Yeah. Of course, even for a plus b whole square, okay, a plus b whole square, we have a method to remember that. But at this stage, you don't remember. Similarly, for every rule, don't try to get into that ideology. Of course, when you are learning Euler graph, I start with, Königsberg bridge problem where actually the Euler graph problem is originated. Actually, not just Euler graph problem originated, the graph theory is originated with Königsberg bridge problem. Okay? See, if you want to learn that way, then you have to start from the beginning. Okay? Yeah. Nice. He says ACD. Complement of a cycle with 15 vertices. See, the simple logic for Euler graph is the only problem which is completely characterized. Means you can easily identify whether it is Euler graph or not by simple property. If and only if condition we are having for Euler graph. Degree of every vertex must be even, then the graph is Euler graph. If degree of every vertex of a connected graph, degree of every vertex of a connected graph is even, then it is Euler graph. Now look here, what is degree of this? 2. Degree of this 3. It cannot be Euler graph, sir. It cannot be Euler graph. Degree of every vertex must be even. You see, degree of this vertex is 2, degree is 2, degree is 4, degree is 2, degree is 2. So here you can start at some vertex, you can cover all the edges of the graph and come back to the starting vertex. You can start at any vertex or one vertex, cover all the edges of the graph and come back to the starting vertex without repeating any edge. Therefore, it is having Euler circuit. Because this graph is having Euler circuit, you call it as Euler graph. But complete graph on 20 vertex, degree of each vertex is 19. If you are having degree of each vertex is even, then it is Euler graph. But here this is not Euler because degree of each vertex is odd. How it can be Euler graph? So that is wrong. Is that clear? That is wrong. Next comes the option A. Next comes the option A. The complement of a cycle with 15 vertices. So here cycle means degree of each vertex is 2. So it is degree of each vertex is 2, sir. So this is cycle graph with 15 vertices. What about cycle graph's complement, sir? What is degree sequence of its complement? 15 vertices means n minus 1. We already done the degree sequence of complement n minus 1 minus d1. That is 15 minus 1 means 14 minus 2. That is 12. That is 12. And that is 12, 12, 12. So here degree of each vertex is 12, which is having minimum degree greater than or equal to n minus 1 by 2. Therefore it is connected, and having degree of each vertex is equal to even. Therefore this is correct. Therefore this is correct, my dear friends. A and D are correct, whereas B, C are wrong. So A you said is correct, C is wrong. Akshita Sharma. Okay, so C is wrong. Okay, hope you understand that. Shall we continue or we call it a day? So homework problems need to be given. So let us take homework problem 1, which is on planar graphs. Two, which is also planar graph. And the final one, chromatic number, graph coloring. Even this you can try this as homework, my dear friends. 3 homework problems to conclude this story. Today I have not given any homework problems. So, oh, this is a tree, problem on tree, homework. This also you can try. So that's it, that's all for today. So remaining 4 problems are homework. Anyhow, I'll share this just now, immediately after the class. I share it in the group, sir. Okay. So these are all for you. GATE preparation free ebooks are available. The links are given in the description box or comment section. You can find it. Okay. And you have some scholarship test which is happening almost every week or bi-weekly. You can just go through that. Please follow our BYJU'S Exam Prep app. Then finally, this free GATE workshops are also happening. On 20th I am taking. Thank you very much, sir. Sir, yesterday's session PDF. Yes, both I'll share, sir. I forgot. I thought I shared, but sorry, I have not shared. So let me share both immediately after the class. First thing which I do is that. No problem. Sorry for interruption. First thing when you are learning the mathematical subjects, don't. See, most of the people not here. Here it's at least, discrete mathematics directly. There are some applications with, algorithms, data structures, I can tell you. When people are learning, engineering mathematics, there they'll ask all this question. They are not visualizing. See, it's not like visualizing, sir. One-to-one correspondence won't happen. That way you can't learn, especially for competitive examination. Am I clear? It's not 1 rule or 2 rule. Okay. So you just need to know the idea, logical idea. Logically, mind should think about that logical idea. Visualize that. It's a graph, na? Graph, everything is visualized. Am I clear? Again, for that, you want a physical application, unnecessary you are wasting your energy, my dear friends. You are giving excuses like, I cannot remember, so I need an example. Okay, so don't play with examples or excuses. Plan, learning things. Okay, your mind can understand, just do it. Got it? That's all for today. And next time, I think I'll be coming up with this algorithms GATE championship series also. There also we solve problems, sir. I'll solve problems from dynamic programming, like matrix chain multiplication, LCS, all these problems I solve it. We'll try to give, even in greedy algorithms we solve it. And of course, divide and conquer, okay? Even graph algorithms, like we have this single source shortest path problems, we have minimal spanning tree problems, okay, spanning tree problem, all that we'll do it. Tomorrow we do not have sessions, sir. I'll announce my sessions in my Telegram channel, Telegram group, my dear friends. Please do join my Telegram group, CS_Sridhar. So the Telegram group is CS_Sridhar. Please join that. You'll find the updates about my classes. Okay, that's all for today. Have a good night. I'll share this PDF immediately in the group, sir. Thank you very much for attending. Okay, please. Thank you one and all.